The first step is we want to identify, is it statically determinate or statically indeterminate? Actually, let me put up our finds while I'm thinking of it here. We want to find the force in every member. We have a member AB, BC, BE, DE, CD, and I'm missing one BD. Again, I'm using all alphabetical notation here just to keep that track a little bit easier on what force is what. And we are given that both of these applied forces are 4 kilonewtons.
Can you explain the second rule for y is a zero force number again?
So here we see if it's the only member that has a component in a specific direction. So like here, AB and BC only act along this line. So let's pretend BD were not here. Then anything that has a component that's perpendicular to this would have to be a zero force member because these are going to cancel each other out along that line, but it can't do anything orthogonal to that line. So if BE were the only, if BD did not exist, BE would have to be zero force because it has a component orthogonal to this, and it's the only member that has a component orthogonal to the line AC.
If P1 wasn't there, BD would still not be a force member then?
If P1 were not here, BD would be zero force from the viewpoint of D.
Okay.
If BD were zero force, then B, looking at B, then EB would also be zero force because knowing BD were zero force, BE would be the only thing with a component orthogonal to AC.
Gotcha.
So that's where you kind of can cascade it down. If you could identify one, it might reveal other ones as 2 force members, or zero force.
Looking at that, how do we know BE is orthogonal to ABC?
In this case, we know because it's going to make a, if this is 30, then we know that this is, by the geometry, I believe it's orthogonal. It actually wouldn't have to be orthogonal as long as a component of it is orthogonal to AC. So actually, it might not be the case that AB and BE are 90 degrees apart. But as long as it has any component in this direction, then it would be a zero force member in that case. Yeah.
So if it's a zero force, does that mean we don't have to use free body diagram for it?
It means that in any free body diagram where it would appear, you would not have to include it because you know the force is 0. So now it could make it look like there's fewer members attached to a pin, and it's less to write and fewer things to solve for. Right, other questions on zero force members? We'll see more examples as we go through. So before we get to a strategy to decide what's the first free body diagram that we draw, we want to determine, or we want to see, is our system statically indeterminate or statically determinate? So looking at how this is arranged and how it's attached to its supports, is this going to be a statically indeterminate or determinate structure? Right? Indeterminate, and why is it going to be indeterminate? Right. There's at A and E, it has pin connections to the wall. So if we were to draw the external free body diagram, we would have 2 reactions at E and 2 at A for a total of 4. And the rule is we have to have 3 or fewer in order to use the external free body diagram to solve it. I'll reiterate, we could draw the external free body diagram. We can get 3 equations out of it that are all correct. But I just tend to skip that step if it's statically indeterminate, because usually there's a way to get numbers out by skipping that step and going right to the pin diagrams. So because it's statically indeterminate, I'm going to jump right to pin diagrams and draw those. Looking at all of our options, we have 5 pins here. Which pin would it seem to make the most sense to start with, because it will only have 2 unknowns attached to it? The only things we don't know attached to C are the 2 members, because we're given P2. So in this case, I would recommend starting at C because only two things we don't know are going to be in the picture we draw at C. We have the applied load, the 4 kilonewtons, and then the forces in the members that are connected to the pin at C. We assume tension, so we're going to assume that to the left will be the force in CD. And also pulling on this pin, the force in BC, and we know that that's at 30 degrees. So again, the benefit here is when I write the equations from this free body diagram, I'll have enough equations to solve for these two unknowns. And actually here, I'll start in the y direction in picture C. Because looking at this picture, BC is the only thing that has a component in the y. So I'll be able to solve for a number right away, right from my first equation. If I started with x, though, I would just come back to it to be able to solve for a number. But if I start with y, I'll have negative 4 plus FBC sine 30 degrees. So from equation 1, my only unknown is FBC. And I can solve for it right now. BC, I'll get a positive 8 kilonewtons, meaning that it's in tension. I still can get another equation out of this first free body diagram by summing forces in the x. I have negative FCD, according to my free body diagram, minus FBC cosine 30. So again, from the picture, it was a negative FCD, it points to the left. A negative FBC, it has its component pointing to the left. I put in my positive value of 8 here, and I come out with FCD is negative 6.92. Meaning that it is in compression. Two of them are done, FBC and FCD. So I can move on now, and now looking at what is the next choice of pin that I want to draw a picture of. But now at D, I'm only left with two things I don't know. So D, if we're doing it by hand, is a good choice to go to next. The external load, FCD. Still making the same assumption. The pictures don't care what the values are that we found, at least for the internal forces. To the left, I'll have DE. And pointing up, I'll have FBD. Again, if I can, I'll start with the y direction here. I'll have a negative 4 plus FBD. So for FBD, I will get positive 4 kilonewtons, and then it's in tension. Again, this is where we want to make sure we're using the picture to write the equations and not the numbers we found, because it did turn out that FCD was negative. We won't reflect that until we solve this next equation. Again, based on how I drew the picture, I'll have FCD to the right, so it's positive here, minus FDE, since it points to the left. At this point, I put in negative 6.92 for my value of FCD, so that way I get the correct value for FDE will be also negative 6.92. So there's only two things left I don't know, so hopefully I might be able to find them both with just one more drawing. And so looking through here, which point could I draw next? Right, now I can draw B because I know BD and I know BC, so there's only two things left, which are, luckily, the two forces I'm looking for. I have the four members acting here. I have BC, acting 30 degrees below the horizontal. AB, 30 degrees above the horizontal. BD is vertical. And FBE is going to also be 30 degrees below the horizontal. But again, we know BD already, and I know BC already, so only two of these are actually unknowns once I fill in the things I know. Well, I don't know. Again, BE, AB, I don't know either. There's not really a better place to start here in terms of directions of forces because they both will have X components and they'll both have Y components. So this will be the only step in this where I will have to do any real algebra in order to solve it. In the X direction, I'll have negative FAB cosine 30 minus FBE cosine 30. And I'll have plus FBC cosine 30 as well. This one actually turns out nicely because I can divide through by cosine 30 to make it a little bit simpler. But I still will have, that makes at least a little bit less decimals to work with. So really it's going to be negative FAB minus FBE plus FBC once I cancel out those cosine 30s. I still have two things I don't know left in here, so I need my sixth equation so they'll have enough to be able to solve for FAB and FBE in the end. So in 6, now if I sum forces in the y direction, I have negative FBD, which I know, minus FBC sine 30, which I know, minus FBE sine 30, plus FAB sine 30. And unfortunately in this one, the sine 30 doesn't cancel out because I have that FBD here. From equation 5 to equation 6, I only have those two unknowns left, FAB and FBD. So if I solve 5 and 6 at the same time, I can find those two remaining values. FAB, I get 12 kilonewtons in tension. And BE, the last one, I get negative 4 kilonewtons, so it's in compression.